Good afternoon, and welcome to today's virtual product review. My name is Lee McGuire, and I am the Director of Marketing and Communications at the Monitoring Association. Thank you very much for joining us today. Before we begin, I'd like to confirm that our audio is working and to introduce you to some of the features of our webinar. May I ask someone to confirm that you can hear by clicking on the raised hand icon on your control panel? Thank you, Marjorie. I appreciate that. We are recording this presentation, and you will receive a link to the recorded presentation in a few days. And now I'd like to welcome TMA member J.R. Andrews from Altronix, who will share some industry game-changing solutions that will eliminate the need for an electrician, dedicated conduit, and wire runs, thus providing tremendous savings by using low voltage installation methods. JR is the National Sales Executive with Altronix. He has over 22 years of experience. Prior to joining the company in 2014, he spent 17 years as a managing partner of PMA Marketing Incorporated, a Cleveland, Ohio-based manufacturer's representative firm. JR is experienced in the design and sales of systems, products, including access control, door hardware, and biometrics, as well as IP video surveillance. JR's focus with Altronix is on enhancing the brand among national accounts, end users, architects and engineers, security consultants, systems integrators, wholesale distribution partners, and other key Altronix accounts. So let us get started. JR, it's all yours.
Hi, thanks, Lee. Good afternoon. Appreciate the opportunity to run through the latest technologies from Altronix. As most of you know, Altronix continues to move at the speed of technology, and today we're excited to talk about a truly industry game-changing solution that we call Tango. But to really understand Tango requires us to first be able to understand what Tango really is and how it operates. So at the end of last year, IEEE ratified the new 802.3 BT standard for PoE. And this new standard increases the maximum PoE power available by utilizing all four pairs of the structured wiring to pass power. You'll find that it's also described as 4P PoE, since high PoE in the past related mostly to a 60-watt type standard, which really at the time was not a standard. 4-pair PoE is now going to be the IEEE standard that will work with 15 watts, 30 watts, so PoE, PoE plus, high PoE, and now of course this 4P PoE, which will get you 72 and then up to 90 watts. So what it's important to remember is that any power sourcing equipment that provides the 802.3 BT standard for PoE is always backwards compatible. And that means that, again, you can plug any device, any power device into a PoE switch or mid-span injector that works to the 90-watt standard, but the power sourcing equipment is only going to pass the power that's required for the PD. So if it asks for 15 watts, that's what it'll get, or 30 watts, so on and so forth. Altronix has a number of power sourcing equipment models on the market. And what we're looking at here on the screen is our 4-port and 8-port version of our PSCs that work to the BT standard. So these are power injectors only. What we're doing here is we're taking the data cables in from the existing switching equipment, and then we are injecting power on all 4 pairs of the cable to deliver up to 90 watts. What's unique about the Altronix mid-spans in this case is that A, they are made in the USA, B, they come with a lifetime warranty, so once you purchase the equipment, any issues that you might have in the future, which we hope would be very few, and we're almost sure will be very few, we will repair or replace the equipment at no charge. The other is that this equipment has a battery charging circuit. So we have the ability to provide battery backup to the devices connected to our mid-span injectors, utilizing what we call an RE2 rack tray that'll house 4 12-volt 7-amp-hour batteries. meaning we can provide battery backup for devices connected right at the IT rack as opposed to at the device itself. More on that momentarily. So Tango. Tango is revolutionizing the power of access control, and it is a 4P PoE driven power supply charger that will deliver both 12 and 24 volts DC simultaneously for deploying access control. It's powered by any 802.3 BT PoE power source up to 90 watts. So we're talking again about the power injectors or mid-spans, the Netway 4BT, for instance, from Altronix, the Netway 8BT, that will be located in an IT rack. We will have Cat 6, Cat 5e technically, or higher cable plugged into it. We'll go 100 meters to this Tango board, which would be located in a power supply enclosure, one of our Trove access and power integration enclosures, and it will be able to deliver both 12 and 24 volts DC simultaneously for access control devices. So it's important to note when we talk about 90 watts of PoE power, when we regulate this power, it can be converted to 6 amps at 12 volts DC and or 3 amps at 24 volts DC. More on the breakout here of the Tango 1B. This board matches the exact footprint of our traditional power supplies, which require 115 volts input. This board now, in the upper left-hand side, will take the 90 watt in from our 802.3 BT power sourcing equipment. On the right-hand side, we're going to be able to provide a relay for PoE power status as well as battery status, 12 volts DC, 24 volts DC, and we've also got a battery charging circuit for lithium iron phosphate batteries. If you are not familiar with lithium iron phosphate battery technology, you can do a quick Google search for LiFePO4, or you can shoot over to the Altronix website where you will find a white paper on this, additional game-changing solution for battery backup in our industry. Bottom left-hand corner of the board, you'll see our data pass-through. So once we have this power supply, the 4P PoE power supply mounted in an enclosure, if we're deploying access control, other devices that require network connectivity, we can plug those directly into the Tango 1B board to drop them onto the network. And then in the right-hand side of the board, you'll see the 8-pin connector. That's for use with compatible Altronix sub-assembly. So now we can stack right on top of this board our power distribution boards or access power controllers that are designed to stack right on top, and we can deliver simultaneous 12 and 24 volts DC to the connected devices. So when we take this idea of a 4P PoE and we put it to work in a hypothetical application here for access control deployment, we use Mercury as our basis for the access controllers, really because it is one of the most widely used brands in the industry. And here we can show you that we have 4 Mercury boards requiring a total of 2,150 milliamps or 25.8 watts of power. That's max current draw for these controllers, so there could be no additional power required by them. And when we add in the card readers, max current draw of 55 milliamps, 8 electric strikes at 150 milliamps, or as you see to the right, 28.8 watts. And then we throw in our request to exit motions or other ancillary devices. In this case, we need 2.55 watts for those. When we use the battery charging circuit right on the Tango board, that's going to take up to 10 watts, leaving us a total of 72.4 watts of power. That number is important because where we talk about bringing 90 watts of power from the power sourcing equipment to the Tango 1B, once the Tango 1B is in operation, it's taking the power that it requires to operate. You have a total of 75 watts available for the access control system. So you can see here from this application diagram, if you will, that we are going to require 72.4 watts utilizing battery charging at the Tango 1B board. Now, as I mentioned previously, we've got the ability to provide battery backup right at the power sourcing equipment using the Altronix RE2 and 4 12-volt 7-amp-hour batteries. So we may be able to eliminate having batteries located in individual enclosures throughout the facility that also have to be serviced and maintained in disparate locations, move that to the IT rack where we're providing the battery backup for the power sourcing equipment, and that's where all the servicing of the batteries would take place as well. Traditional access control power requires an electrician to provide 115 volts AC to the input of the power supply. When we think about whether that's part of the security professional scope of work, many times it's not. But again, it's going to save the end user money on the deployment of high voltage throughout a facility. And then there's additional costs associated with that. When we think about the conduit that's required, the fact that it can't run in the same cable tray as other low voltage cabling, etc. And then when we get into applications for service and maintenance, ongoing maintenance of the system, if we have to service an access control enclosure that has our power supplies and access controllers, that high voltage is there. It's going to require some industry regulations such as lockout, tagout. In the case of the new access control power, we see on the bottom, we're going to use a security technician to wire up the power input because we're literally just plugging in the Cat5e or higher cable into the Tango 1B board. Stacked on top of the Tango 1B board is an access power controller to provide switch power for our door hardware. And then we can bring raw 12 volts DC out of the Tango board, deliver that to our power distribution board, which can then in turn provide fuse protected power to our access controllers. And of course, always an added benefit of lithium iron phosphate batteries. So if we take this into a larger access control deployment, and let's say we had to deploy 32 doors of access control, we could leverage our Netway 4 BT power injector, provide up to 90 watts to 4 separate Trove access and power integration enclosures, each one having a Tango 1B board, and have 32 doors of access control, all done with low voltage cabling, low voltage wired installation methods, including being able to run the cable through the same cable trays as the low voltage cabling, and also provide battery backup at the IT rack if we choose. Altronix believes that this technology is as it is emerging, is not the end. And so what we've done now is given the designers and technicians as well as integrators the ability to deploy Tango just to power their door hardware if they choose, or just their access control and ancillary devices, really any devices that require 12 or 24 volts DC. So what we're looking at here is a Tango 8P. This is a Tango board with a power distribution board stacked on top to provide aux power or constant power to devices such as, again, request to exit motions, electric strikes, other ancillary devices. The middle portion here, the Tango 8A, that is a Tango 1B board with an ACM S8 access power controller stacked on top that has access control trigger inputs and relay outputs for the door hardware. And then we've got the Tango 8AP. This is going to be able to provide switching power for our door hardware utilizing our ACM S8 and our PD S8 stacked right onto the Tango board to provide aux power. What's unique about this situation or solution, as we look here at the diagram or picture, we can see that we're delivering both 12 and 24 volts DC, both to the power distribution board as well as to the access power controller. On our website, we have an award-winning Trove design tool. We have already added the Tango 1B board as an alternative to our traditional ULX or eFlow series power supplies, which require high voltage. Or now we can drop a Tango 1B into the enclosure, stack our power distribution boards or access power controllers on top, and complete a full system design utilizing Tango. Coming soon, and very soon, might be today or tomorrow, we will have on our website our Tango design calculator. That's going to allow the system designers to be able to take the maximum current draw of all the devices that they're preparing to deploy, put them into our calculation tool, provide you with a number of total wattage required, which can also be printed and used for submittals. Stay tuned for that. If there's any questions or if you'd like to learn more about the Tango 1B product or any Altronix products or solutions, please don't hesitate to reach out. My contact information is on the screen. I'm happy to answer any questions you might have or connect you up with our RSMs or field reps for more info.
Thank you very much, JR. That is an exciting product, and we're so happy you were able to share it with us. Attendees, do you have any questions? just wait about 30 seconds here, see if anybody has any questions. Okay, I have one for you, JR. Are there cabling types beyond Cat 5e that are better suited for 90 WPOE?
Yeah, that's a great question, Lee. So, when we talk to the cabling manufacturers, there are certain things that have to be taken into consideration. In general, a Cat 5e cable is able to deploy up to 90 watts of power. But when we start thinking about how many of those cables we might be deploying in a bundle, there is going to be some additional heat generated. And the cabling manufacturers also like to talk about connectors, making sure that the connectors are designed to the higher wattage. So I would say check with your cabling manufacturer. The folks at Belden or Superior Ethics, General Cable, etc. They can probably give you a better idea of what you'd want to do from a deployment in terms of the cabling infrastructure. But no, the Cat 5e will pass 90 watts.
Okay, thank you. Okay, we have one more question. If I need power monitoring, can I substitute the Link 8 ACM for the PDS-8, and will it stack on to the Tango board?
Yeah, that's another great question. So the Tango board has that 8-pin connector on it. Currently, our Link 8 ACM has a similar 8-pin connector, so we could stack that on top of the Tango 1B board. So in place of a traditional ACM S8, this would give you network connectivity now to be able to monitor, control, and report power for the 8 devices that you have connected to that. And our Link 8 PD is currently going through a little refresh redesign that's going to incorporate that 8-pin connector. It could still be used to stack on top of a Tango board. We just wouldn't use the actual pin connection between the Tango 1B and the Link 8 PD today. We would just use wire jumpers and go right from the Tango board into the Link 8 PD to deliver both 12 and 24 volts DC. But that would also get you network monitoring there.
Great. Again, I'd like to thank you, JR, so much for this presentation, and to each of you for attending this virtual product review. If you have any additional questions, please don't hesitate to provide those on your follow-up evaluation, or you may contact JR at the information that you see on your screen now. If you are listening to the review of to this review as a recording, you may also visit Altronix website at www.altronix.com. Don't forget to complete the very short survey that you'll get at the end of the webinar. Your feedback is very important to us. Our final VPR for 2019 is next week, so please take a look at the TMA website to learn more and register to attend. This concludes this review for today. Thank you so much.